Awesome. Welcome, everyone. I'm so happy to have all of you here to join us in this virtual Lunch and Learn webinar. Today, we are here to talk about Robo Wunderkind as a tool that can be used to support teachers incorporating those New York computer science and digital fluency standards. My name is Jamie Guidry. I am the Educator Success Manager with Robo, Midwest native. But have been in the DMV, the DC area for about 10 years now, former educator. And I wanted to just kind of share this quote that kind of resonates with me in terms of the role of the teacher, right? Creating conditions for invention rather than providing ready-made knowledge. And I think that's part of why we're all here today, right? So I'm happy to have some like-minded folks to share in this journey to create this type of learning space for students. With us today, we have Tracy Lescult, Education Technology Coach and Librarian. Hey, Tracy. Lori, Coordinator for Instructional Technology Programs. And Andrew Ferrone, Coordinator for Model Schools. Thank you for being here with us. So these folks are have already used Robo Wunderkind with their students, and I will give them an opportunity to share their perspectives and their experience with regard to how the program aligns with those New York computer science and digital fluency standards. But first, I'd like to introduce you to Robo Wunderkind. What is Robo Wunderkind? It's ultimately a program that was designed to help districts like you achieve your overall STEAM goals. We do that by supporting students, teachers, and administrators. With students, it's all about igniting that curiosity for STEAM, because research shows that the earlier students are exposed to STEAM and coding, the more likely they are to pursue STEAM in their academic and professional careers. We also know that teachers can be overwhelmed, right? There's the lack of time that limits that STEAM integration. In a few slides, I'll share with you our STEAM Hub and how our activities help drive that integration into math and ELA and other subject areas. And lastly, we're constantly hearing from administrators that a challenge with STEAM programs is their overall sustainability, right? Parts break down, teachers leave the district. So that's why we've developed this all-in-one STEAM solution, which I'll share with you in the next few slides. Okay, but first let me show you what it looks like for students in the classroom. Here you can see the Robo Wunderkind journey starts with discovering what's possible. For most students, that usually involves building a flashlight. You can see they've just combined a few components, and they already have built something that's a real world representation, right? Something that they see in their everyday lives, and they've lit up the room. Once students they can see what's possible with the modules in our program, they progress to learning the design process. This is where they're challenged to build a robot that can achieve a specific purpose, right? Such as a drivable car. And what this does is it forces students to consider trade-offs and criteria and constraints, right? And also the relationship between hardware and software. And then finally, students become experts in the Robo Wunderkind technology. It again becomes about exploring what's possible. Students love to create their own robots, right? We've seen everything in our classrooms, from cat feeders to candy dispensers, homework completers, and of course, the robot that cleans their classroom or their bedroom, right? But putting this all together, what we've done is built an overall experience that helps districts achieve their STEAM goals. Again, igniting curiosity for students and building sustainability across staff. This infograph, you can see those 4 components to the Robo Wunderkind experience. The core of our product is, of course, that modular robotics kit and the coding app, where teachers are immediately able to embed Robo into their classrooms because they have everything they need. You can see number 2, the standards aligned curriculum and resources that really allows students to immediately embed. They have the lesson plans, the student tutorials, that's all in our STEAM Hub. When we look at building the capacity of teachers, right, schools and districts are successful with Robo because our approach to training is a little bit different. We consider the initial implementation, of course, right? But then also the challenges of building that sustainable ecosystem. So we initially train the core set of teachers in Robo Wunderkind and map the school's curriculum, but then we'll continue that training, and it's meant to build the capacity of teachers as they move further into the curriculum and the implementation. And then when we look at number 4, we're going to reinforce the implementation by assessing the success year after year in training new teachers and supporting that deeper integration into the curriculum. So enough about me. Let me give you an opportunity to see the tool in action. I'm going to hand off to Matthias. He will do a hands-on demo. I'll stop sharing.
Thank you, Jamie. I will quickly jump in now and share with everyone how the tool actually looks like and how it works. You can see the robotics kit on the screen right now. This is how it looks like. There are building blocks. They're color-coded, super easy and simple to build. And the second part, obviously, is our coding app. Can everyone see my app now?
Yep, we can see it.
As well as the kit, perfect. And you can see here on the top, you have the live, the code, the Blockly interface. There are 3 interfaces. They're super easy to use, especially the live and code are very special because students are not required to read and write. And the live interface is basically like a remote control, and the code is a icon-based coding interface. And then we have the Blockly, which is basically scratch coding, which you probably know from a lot of other tools. I will quickly show you a project in our code interface today. We have different tutorials here, or we can also start from scratch. When you use a project from our curriculum, you often use projects from scratch and let the students code their own code without pre-made designs. But to get started, the pre-made designs are super easy to use. So for example, I choose the magic flashlight. You can see there are some building instructions here. And I am now using the orange main block to connect the LED light. And you can see also my app tells me, oh, you've built the first module the right way. And when I connect the second part, I'm actually ready to code, right? And now you see a pre-made code with this interface. I can click in here. I can change the color. I could also adapt this code by drag and dropping other actions. But let's keep it simple for today. I press play, and my flashlight is now able to start executing the code. So if I press the button, I switch it on. If I press it again, I switch it off. And that's just one project. It's a flashlight. I could also start to use motors here to build a robot that can move. And you can imagine a first grade classroom. As soon as something moves, students are getting really engaged. And as you attach different modules, your app also shows you other options for coding. So in this case, I've built something that can move. I also have the motion now. I could, for example, drag and drop the turnaround action onto the action that's already there, or just create a new code. And let me just quickly show you how that works. If I press play now, my robot executes the code I've just made. I could add other actions after this, connect them with each other to build sequences, or also add if conditions with triggers onto the code. So that's a real quick introduction to how the coding interfaces look like. We can also save these projects and then open them up later on if we want to. You've seen the robotics kits now, and you've seen the coding app, but where do we get the content from and how do we know what to teach? This is STEAM Hub. This is the platform for teachers. And here you can see there's our library. We also have on-demand training here. We have a community and we have a competition every year. And you can filter here. Do you want to do a quick activity? Do you want to do a lesson? Do you want to do a project which goes over weeks? How much time do you have? What grade are you teaching? And also what subject do you want to use this in, right? You can use this in math, ELA, social studies, science, but of course also in STEAM, robotics, engineering, computer science. We have resources here that support you as a teacher in the classroom, like rules, how do you build routines. There are cheat cards for you where you see what each of the modules do. But we, of course, also have the lesson plans. And I'll just quickly pull up one lesson plan. This is a social studies and robotics project. It's called My Town. There's 3 45 minutes lessons included. Here you can see the lesson plan for you as a teacher. We always use the CSTA and ISTE standards, as well as the Common Core for Math and ELA and the NGSS standards for science. But of course, we also have a crosswalk to the New York Computer Science and Digital Fluency Standards, which we will show you, share with you in this Lunch and Learn session, as well as in the follow-up email. And then here you can see the student slides. And if we build a town, we need to define our needs and wants. There's a video that introduces the projects to the students. We define the project goals. We define what purpose means, right? Any character, any machine in a town has a specific purpose. And then we start to build different robots. For example, the school crossing guard. We have the teacher. We need a mail truck. We have a grocer, fire truck, family car. A lot of different robots. And you can see this could be also a project that goes over a week. Depends on how you want to use this project. But the most important part is we are connecting the computer science, coding, STEAM projects with social studies and anything that's already in the curriculum and teachers are already teaching every day.
Thank you, Matthias. And as he mentioned, we have created a crosswalk for you, which is why we're here, right? How does this align to the computer science and digital fluency standards of New York, right? So we'll share that crosswalk with you at the end. I don't want to distract you by having you look at that right now. So we'll drop that link into the chat at the end of the Lunch and Learn. But let's go ahead and talk to your colleagues. We have our panel guests that I introduced here with us. We'll start with Andrew. Thank you for joining us and being willing to share how you've been able to use Robo Wunderkind. And let's start with an overview of how were you introduced to Robo?
Sure. Thanks, Jamie. So we have Robo Wunderkinds in our model school's learning library. So I guess I'd say Lori would be the one that introduced me to Robos. I know Tracy had used them a little bit before. This year was my first experience with Robo Wunderkind. So what we do is we loan them out to area districts. Sometimes that comes with a brief tutorial. Other times I'm able to actually be in the classroom and go through different projects with different students using the Robos, which is always fun.
That's awesome. Now, I do remember from our discussion previously, I thought was interesting, your use scenario, you used Robo with middle schoolers, correct?
Yep. Yeah. So it was in an area district. It was a middle school, like STEM club, and they were also using it in the actual classroom. But so we went in, they had a little bit of time to like fool around with Robo Wunderkind ahead of time. And then the teacher and I just gave them a very general project where they had to build and code a robot that performs a task. And so in previous work, what we were noticing is as students work together, they almost kind of divided up naturally into like students that were builders and students that were coders. And you could see them start to do that. So for this, looking at the CSDF standards too, which talk about career readiness and making that connection, we actually had them within their teams create a hardware engineer expert or a hardware lead and a software lead. And it was nice because it kind of let those students who it let more students experience success in different ways within the same project. So they were able to take on multiple different leadership roles. And throughout the project, as you can imagine, it definitely hit that computational thinking and network system design for sure, but also starting to connect it to real world careers for those students to see, hey, this is something that exists. This is something that I can translate into a job down the road. So it was really great.
Oh, that's awesome. Well, then let's jump into Tracy. I'd love to hear how you've used Robo. Tracy, are you there?
Sure. Yeah.
Yeah.
Hi. So similar to Andrew, I also use the Wunderkinds that we have in our learning library. I do more classroom visits where I stay with the classes, and that's what I've done with the younger classes. I've used it with one pre-K class, generally the others, the younger ones, K through 2, and they've all had a great time. We start together with your app, and we do the model lesson. I think the party twirler, we do that one together and walk through the steps. They really like on the app and the iPads how they can manipulate the image to see it from all angles. It helps to see how things fit together. So we generally do the first one together, and then I sort of let them play and just figure it out how to follow the other tutorials on their own and just see what they can make. A lot of them eventually move on to making their own robots and coding them as well.
That's awesome. And I see you added, you wanted to share the Thanksgiving Day parade. Talk to us about that.
Yep. So I believe that was a first grade teacher. She was reading Balloons Over Broadway with her class, and they were making their own floats to connect to the lesson with the book. And she wanted the floats to actually be driving along a parade route. You can sort of see she mapped it out with masking tape on her carpet. So we made their robos into little parade tractors, kind of, and then they drove them around the carpet to follow the route for the parade. And they had a great time.
Oh my goodness, that's awesome.
I believe that's also, she had asked me to do it because she was reading the book, but then I checked on the Steam Hub, and I think you have that as a lesson also. So we utilize that part as well.
Yeah, we do. That's great. I love to see our projects. You'll have to make sure you take more pictures and send them to
I'm
me.
not great at
Every
that.
time you're there, we're gonna make you go famous.
Awesome.
Oh my goodness. Okay, so Andrew, Tracy, thank you so much for sharing your experience. I also have with us Lori, and I'm excited that Lori's here because Lori has been with us from the beginning. She was one of our first users, believed in Robo, and you very clearly saw the alignment between these standards and our product, and jumped right in. So I'm happy to have you here. You've heard from your colleagues. Is there anything additional that you'd like to share out in regards to the CSDF standards, your experience with Robo?
Yeah, no, the Robo Wunderkind, actually, Deanne, who's on this call, introduced me, brought me over to meet Matthias and see them in action at a conference. And that's how we ended up purchasing them for our learning library. Last year was our first year with them. We were able to kind of jump into some elementary classes, like kind of like Tracy, doing some of the beginner activities that get the students engaged in it. For me, it's the build that is maybe a little bit different. It's much more hands-on than some other robots. Other ones, you take it out of the box and you just, you code. That's the big part of it. But because they actually get to build these, I feel like there's a little bit more creativity, definitely more tie-ins with the networks and systems design, which traditionally, when you look at our computer science standards, that has been the more difficult one to find tools that kind of fit with how we can do them in the classroom. And like Tracy showed, you can tie it into whatever you're doing in the classroom. You can create that correlation to what you're already doing. So it doesn't have to be an additional thing other than bringing in the coding. And like you both showed, when you're doing the coding, it's very hands-on, it's very visual, which makes it accessible for all of our students. So we like how simple it is as far as the fact that it's so hands-on, and that it adds something to the standards that are traditionally hard to figure out.
I think you're right. Part of the challenge that I've heard across, multiple districts is finding that tool where you have that engineering design process in there as well, right? Finding a tool that hits all of these different standards can be challenging. So I'm happy that you're finding success with Robo.
Yeah, absolutely. Yeah, it really is the most hands-on that we've had, and for the littles, that makes it unique in that way, because they connect easy, they're easy to use, and they really can help the students use their imagination, which is important.
Well, that's great. So at this point, So I've had some wonderful guest speakers. You've heard from me. I, of course, think Robo is great. So I'm going to say great things, but you've also heard from your colleagues. I'd like to open the floor for any questions that you might have. If you have not seen Robo in action, or if you have any questions for any of our panelists today.
Hi, quick question. This is Leslie.
Hi, Leslie.
First of all, I love the fact that you were able to show, is it Matthias or Matthias? I'm sorry.
Matthias.
Very effective use of camera to actually show the kit in action. What you showed us, is that pretty much the de facto kit, or are there other modules that you can add on? Is it basically all in one?
This is all in one. This is one kit. Any school, any district that starts using Robo Wunderkind will receive all modules that we have.
I noticed also that the coding that you demonstrated was on an iPad. What are some other platform accessibility? So we have a lot of Chromebooks in this region.
Yes, so 90% of our users use Chromebooks. So we have Android, iOS, Windows, Mac OS. But we also launch our web application in the fall, which means you'll be able to access our app anywhere, browser-based.
And one other question. This was something that I saw shades, obviously, of other modular robotics. I thought of Kubelets immediately, kind of like bits and pieces of everything. And I thought I saw a couple of minifigs on there from Lego. Did I catch that right?
Yeah.
I saw a picture of some.
Yes, so we use brick adapters, which you can use to adapt Lego on it or any brick. The modules, they are colorful, so it reminds you on Kubelets. That's what we hear a lot because Kubelets is also a very known product. There's a big difference. Our modules are not pre-coded, or they cannot do anything before you code those, right?
Right.
This is the motor, but if you attach the motor to the robot, it doesn't do anything. You need to connect it to an app and then actually tell it what to do. Like in real world, you build a robot, but then you need to add some software to it, some code to make it execute. Yeah, that's the biggest difference. Yeah.
And so I'm thinking about other kind of robotics crossovers with coding. Is there any emulation that you have in the platform itself? So if you wanted to do a simulation, let's say you wanted to test a code out, but you wanted a virtual robot, is that part of it, or does it really rely on that physical kit?
That's a really good question. It's not there yet. And so, yeah, it's something that is definitely interesting to develop, which we consider, but it's not there yet. Yeah.
Okay. Thank you. I appreciate it.
I forgot to add, Jamie, one thing that when we had discussed, we thought was a really important point is how responsive you are when we have issues that you email back, and you're very helpful and responsive with all of our problems. So I wanted to make sure I added that. I forgot the first time, but definitely a pro.
Thank you. And I think, that's important, not because it's me, but because, when we think about scalability and sustainability, right? And oftentimes if there is a problem and a teacher can't have it resolved, right away, then what happens to that tool? It kind of gets pushed to the side and they move on because we've got plenty of things to do as teachers, right? So, I'm happy to provide that support. And I think that's another thing that makes the program unique. And sustainable for teachers and for entire districts.
I have a question for my colleagues that presented, and I be candid and honest. We, in our region, we don't have a lot of districts that have dedicated STEM programming or teachers or talent. So everyone adopts a piece of this and tries to find a home. And you understand what challenges there are. Nobody in an elementary classroom, I said, nobody signed up to be a coding teacher or, talking about engineering. So just tell me the story in terms of what you've seen, a teacher's ability to, first of all, maybe allow the experience to happen in the room with the help of an instructional tech coach. That's kind of one level of adoption. But how would you rate the ease of adoption for a regular classroom teacher to just say, this is something that I'm going to learn alongside my kids, and I know there's a coding component and some of it may look foreign. How does this fit into the other robotics kits that we've seen? would you generally say that, I mean, there's a lot of different factors, but a teacher adoption, ease of adoption scale? And again, you could be honest, because you could say it depends, or certain pieces like the physical building part might be easier than the coding, but obviously the two of them want to fit together. So what has your experience been?
I'll jump in first, and then I'll throw it to Andrew, because Andrew, I know you've done a lot more drop-offs this year where teachers haven't had a lot of training on it, so you can speak to that as well. I tend to do it more guided. I know Deanne, who's on the call, she does a lot more guided, where she's pushing in to be the coach with the teacher to kind of support. But we do find that, this is very subjective, but the teachers that are more comfortable with let's figure it out together are very good with taking on these robotics. Somebody that's brand new to it, I would say you want to be the guide on the side
Sure.
to really help them out. I think that's just a better model. This one, because it's so hands-on as far as like walking you through the process, and the lessons are so step-by-step, as long as you can follow directions, you can get there, especially with the beginner ones that they're starting with, like making that first, spinner kind of thing. Those kind of activities are pretty, they're so direct that it's easy to kind of follow. When you're getting into the more creatives, that's something you're going to want to lean, either they've had experience before or they need to, get some support. We don't offer any training to the teachers that borrow it. They just borrow the products, which is why I said yeah. So Andrew, you want to add to that too, or Liz, you have a follow-up question?
Yeah, like I can think of, I can think of one teacher, like in particular, who didn't have any awareness of Robo Wunderkind, thought it was a cool thing, and I dropped it off, and I didn't give any training. But the teacher, kind of like Laura was saying, was of that attitude of, hey, let's figure this out. And she, when I picked him up, I was talking to her and I was like, how'd it go? And she's like, the students taught me more than anything else. She's like, we just kind of jumped in. She used the Steam Hub. She found that extremely helpful to have that. But she said she was very happy with it overall. She said all the students were able to build, they were all able to code, and she learned more after introducing it to the students from the students than, because she's, just they were better at it than she was, is what she would say. And that was an upper elementary class. And she's like, it was.
The other thing, your lending library is something that I envy, and I really wish we could find a way to make that work. But the other thing that came to mind is, this seems to me, so if you have a teacher that has, I have a district that's thinking about doing something with third grade students with PBL, with coding, and it's a one-time project. It doesn't have to be this long trajectory, very, very deep. It sounds to me as if this is the perfect opportunity to say, look, if you want to give your kids an experience, if you're doing something in social studies or ELA and you're looking at impacts of computing and you're thinking about cities and all of that great stuff, it's not a big ask. You could actually use this to design a lesson unit or activity without it needing a long scope and sequence. But if you're a STEAM teacher, it had like low floor, high ceiling. So it seems to me one of those kits that could easily work if I just want to try something now that's going to last 2 weeks. Or maybe even, one period, if I want to give my kids some exposure. To me, that seems to be the appeal. I don't know if that was by design or just the supportive resources that you have. But
that's why it works so well with the lending library, because they can't have it for the year. Like, they can only have it for the maximum of like a month usually. So it works well in that capacity, where it doesn't need to be their entire curriculum type of thing.
I had a question regarding, I think Robo Wunderkind was moving toward the upper grades in elementary, and I wanted to know how well did that go with the kids, with the integration of the other courses, as well as with the students learning it. Because for my district, we have Robo Wunderkind with our smaller students, but it would be this group of students getting in the middle without any pre-knowledge of computer science or anything. How would that go? Because we're working with you guys with our robotics school.
Like I said, my main experience this year was in a middle school STEM club, and I never felt like they topped out. Because, well, one, they're using Blockly, so that made it a little bit more like they had to actually do a little bit more coding than they were, or more in-depth coding than they were doing at the younger ages. But there's just so much you can do and invent and create with them. I mean, we had students create like a portable cup holder that transferred, you know, the drink from one person's desk to another person's desk. Like there's just so much creativity and building you can do. I mean, with them, you think about just I equate it to like Legos, but that have so many more capabilities where you never really get too old, or you can never really there's always something more to learn and practice and do. And that's what I like about Robo. I don't see it like topping out. Like there's always, so with the older kids, I would say I wouldn't have any qualms about um them having the capabilities to do it and them like ever being above it, because it's definitely applicable.
Well, folks, it is 12 o'clock. That brings us to a close. If you have additional questions that you weren't able to get in here, you can always shoot us a message and we can set up a meeting with you individually. Again, contact at robowunderkind.com if you'd like to have a sample and set up a play session and onboarding with me. And of course, your link for the New York Computer Science and Digital Fluency Standards alignment crosswalk is also in the chat for you.